Greetings, fellow learners. Welcome to IziCodeCraft. Let's turn our experiences into lessons. Hit that like button, subscribe to the channel, and join the journey. So, in the last episode, we went through the first part of the How Does the Web Work lesson of the prerequisite section. We did a couple of the assignments, and now we will go through the rest of it and do the knowledge check. So, the next one will be read about how different parts of the web interact with each other. Okay, that's the first part of the assignment. Let's go. How the web works provides a simplified view of what happens when you view a web page in a web browser on your computer or phone. This theory is not essential to writing web code in the short term, but before long you'll really start to benefit from understanding what's happening in the background. Understanding the foundational concepts of how the web operates is crucial as you delve deeper into web development and usage. Clients and servers. Computers connected to the internet are called clients and servers. A simplified diagram of how they interact might look like this. Clients are the typical web user's internet-connected devices, for example, your computer connected to your Wi-Fi, or your phone connected to your mobile network, and web accessing software available on those devices, usually a web browser like Firefox or Chrome. Servers are computers that store web pages, sites, or apps. When a client device wants to access a web page, a copy of the web page is downloaded from the server onto the client machine to be displayed in the user's web browser. Understanding the roles of clients and servers clarifies how data is exchanged between your device and the internet. The other parts of the toolbox. The client and server we've described above don't tell the whole story. There are many other parts involved, and we'll describe them below. For now, let's imagine that the web is a road. On one end of the road is the client, which is like your house. On the other end of the road is the server, which is a shop you want to buy something from. In addition to the client and the server, we also need to say hello to your internet connection. Allows you to send and receive data on the web. It's basically like the street between your house and the shop. TCP/IP, Transmission Control Protocol, and Internet Protocol are communication protocols that define how data should travel across the internet. This is like the transport mechanisms that let you place an order, go to the shop, and buy your goods. In our example, this is like a car or a bike or however else you might get around. DNS, Domain Name System, is like an address book for websites. When you type a web address in your browser, the browser looks at the DNS to find the website's IP address before it can retrieve the website. The browser needs to find out which server the website lives on, so it can send HTTP messages to the right place, see below. This is like looking up the address of the shop so you can access it. HTTP, Hypertext Transfer Protocol, is an application protocol that defines a language for clients and servers to speak to each other. This is like the language you use to order your goods. Component files. A website is made up of many different files, which are like the different parts of the goods you buy from the shop. These files come in two main types. Code files. Websites are built primarily from HTML, CSS, and JavaScript, though you'll meet other technologies a bit later. Assets. This is a collective name for all the other stuff that makes up a website, such as images, music, video, Word documents, and PDFs. Recognizing these components provides a holistic view of what makes up a functioning website. So what happens, exactly? When you type a web address into your browser, for our analogy that's like walking to the shop. 1. The browser goes to the DNS server and finds the real address of the server that the website lives on, you find the address of the shop. 2. The browser sends an HTTP request message to the server, asking it to send a copy of the website to the client, you go to the shop and order your goods. This message, and all other data sent between the client and the server, is sent across your internet connection using TCP/IP. 3. If the server approves the client's request, the server sends the client a EA200 occasion message, which means of course you can look at that website. Here it is and then start sending the website's files to the browser as a series of small chunks called data packets. The shop gives you your goods, and you bring them back to your house. 4. The browser assembles the small chunks into a complete web page and displays it to you, the goods arrive at your door, new shiny stuff, awesome. Understanding this process helps you grasp how web pages are retrieved and displayed in your browser. Order in which component files are parsed. When browsers send requests to servers for HTML files, those HTML files often contain link elements referencing external CSS stylesheets and script elements referencing external JavaScript scripts. It's important to know the order in which those files are parsed by the browser as the browser loads the page. The browser parses the HTML file first, and that leads to the browser recognizing any link element references to external CSS stylesheets and any script element references to scripts. As the browser parses the HTML, it sends requests back to the server for any CSS files it has found from link elements, and any JavaScript files it has found from script elements, and from those, then parses the CSS and JavaScript. The browser generates an in-memory DOM tree from the parsed HTML, generates an in-memory CSSOM structure from the parsed CSS, and compiles and executes the parsed JavaScript. As the browser builds the DOM tree and applies the styles from the CSSOM tree and executes the JavaScript, a visual representation of the page is painted to the screen, and the user sees the page content and can begin to interact with it. Knowing the sequence in which files are processed helps optimize website performance and user experience. DNS explained. Real web addresses aren't the nice, memorable strings you type into your address bar to find your favorite websites. They are special numbers that look like this. This is called an IP address, and it represents a unique location on the web. However, it's not very easy to remember, is it? That's why the domain name system was invented. This system uses special servers that match up a web address you type into your browser, like mozilla.org, to the website's real IP address. Websites can be reached directly via their IP addresses. You can use a DNS lookup tool to find the IP address of a website. Understanding DNS helps you appreciate how domain names translate into IP addresses for accessing websites. Packets explained. Earlier we used the terms packets to describe the format in which the data is transferred between the client and server. What do we mean here? Basically, when data is sent across the web, it is sent in thousands of small chunks. There are multiple reasons why data is sent in small packets. They are sometimes dropped or corrupted, and it's easier to replace small chunks when this happens. Additionally, the packets can be routed along different paths, making the exchange faster and allowing many different users to download the same website at the same time. If each website was sent as a single big chunk, only one user could download it at a time, which obviously would make the web very inefficient and not much fun to use. Understanding packets clarifies how data efficiency and reliability are maintained across the internet. And the next part is, read this MDN article about how a DNS request works. What is a domain name? Domain names are a key part of the internet infrastructure. They provide a human-readable address for any web server available on the internet. Any internet-connected computer can be reached through a public IP address, either an IPv4 address or an IPv6 address. Computers can handle such addresses easily, but people have a hard time finding out who is running the server or what service the website offers. IP addresses are hard to remember and might change over time. To solve all those problems, we use human-readable addresses called domain names. Understanding domain names is crucial as they provide human-readable addresses for accessing web servers. Structure of domain names. A domain name has a simple structure made of several parts. It might be one part only, 2, 3, separated by dots and read from right to left. Knowing the structure helps identify the purpose and scope of different domain names. Each of those parts provides specific information about the whole domain name. TLD, top-level domain. TLDs tell users the general purpose of the service behind the domain name. The most generic TLDs, .com, .org, .net, don't require web services to meet any particular criteria, but some TLDs enforce stricter policies so it is clearer what their purpose is. For example, local TLDs such as .us, .fr, or .se can require the service to be provided in a given language or hosted in a certain country. They are supposed to indicate a resource in a particular language or country. TLDs containing .gov are only allowed to be used by government departments. The .edu TLD is only for use by educational and academic institutions. TLDs can contain special as well as Latin characters. A TLD's maximum length is 63 characters, although most are around 2 to 3. The full list of TLDs is maintained by ICANN. Label, or component. The labels are what follow the TLD. A label is a case-insensitive character sequence anywhere from 1 to 63 characters in length, containing only the letters A through Z, digits 0 through 9, and the hyphen character, which may not be the first or last character in the label. Here are some examples of valid labels. The label located right before the TLD is also called a secondary level domain, SLD. A domain name can have many labels or components. It is not mandatory nor necessary to have 3 labels to form a domain name. For instance, www.inf.uk is a valid domain name. For any domain you control, e.g. mozilla.org, you can create subdomains with different content located at each, like developer.mozilla.org, iot.mozilla.org, or bugzilla.mozilla.org. Buying a domain name. Who owns a domain name? You cannot buy a domain name. This is so that unused domain names eventually become available to be used again by someone else. If every domain name was bought, the web would quickly fill up with unused domain names that were locked and couldn't be used by anyone. Instead, you pay for the right to use a domain name for 1 or more years. You can renew your right, and your renewal has priority over other people's applications. But you never own the domain name. Companies called registrars use domain name registries to keep track of technical and administrative information connecting you to your domain name. Note, for some domain name, it might not be a registrar which is in charge of keeping track. For instance, every domain name under .fire is managed by Amazon. So, you pay for the right to use a domain name for a specified period. Registrars manage domain name registries to ensure technical and administrative connectivity. Understanding ownership clarifies the leasing nature of domain names rather than outright ownership. Finding an available domain name. To find out whether a given domain name is available, go to a domain name registrar's website. Most of them provide a IziCodeCraft service that tells you whether a domain name is available. Alternatively, if you use a system with a built-in shell, type IziCodeCraft command into it, as shown here for mozilla.org. And this will output the following. As you can see, I can't register mozilla.org because the Mozilla Foundation has already registered it. On the other hand, let's see if I could register a funky domain name .org. This will output the following at the time of writing. As you can see, the domain does not exist in the IziCodeCraft database, so we could ask to register it. So, to find out whether a given domain name is available, use a registrar's IziCodeCraft service. For instance, Mozilla.org is registered by the Mozilla Foundation, while unregistered names can be requested. Checking availability ensures you can secure a domain that fits your needs. Getting a domain name. The process is quite straightforward. 1. Go to a registrar's website. 2. Usually there is a prominent Get a domain name call to action. Click on it. 3. Fill out the form with all required details. Make sure, especially, that you have not misspelled your desired domain name. Once it's paid for, it's too late. 4. The registrar will let you know when the domain name is properly registered. Within a few hours, all DNS servers will have received your DNS information. Note: in this process, the registrar asks you for your real-world address. Make sure you fill it properly, since in some countries registrars may be forced to close the domain if they cannot provide a valid address. Following steps ensures a smooth acquisition process and avoids mistakes. DNS refreshing. DNS databases are stored on every DNS server worldwide, and all these servers refer to a few special servers called authoritative name servers, or top-level DNS servers. These are like the boss servers that manage the system. Whenever your registrar creates or updates any information for a given domain, the information must be refreshed in every DNS database. Each DNS server that knows about a given domain stores the information for some time before it is automatically invalidated and then refreshed. The DNS server queries an authoritative server and fetches the updated information from it. Thus, it takes some time for DNS servers that know about this domain name to get the up-to-date information. So, DNS databases on global servers are periodically refreshed from authoritative name servers, ensuring updated domain information across the internet. Understanding DNS refreshing aids in comprehending how domain updates propagate globally. How does a DNS request work? As we already saw, when you want to display a web page in your browser, it's easier to type a domain name than an IP address. Let's take a look at the process. 1. Type mozilla.org in your browser's location bar. 2. Your browser asks your computer if it already recognizes the IP address identified by this domain name using a local DNS cache. If it does, the name is translated to the IP address and the browser negotiates contents with the web server. End of story. 3. If your computer does not know which IP is behind the Mozilla.org name, it goes on to ask a DNS server, whose job is precisely to tell your computer which IP address matches each registered domain name. 4. Now that the computer knows the requested IP address, your browser can negotiate contents with the web server. Knowing this process helps appreciate the role of DNS in translating user-friendly domain names to machine-readable IP addresses. Hopefully you went through all the assignments too first, and now you are just reviewing other people's answers, right? If not, go through the assignments, try to learn it, and have some notes on this knowledge check on your own, and then come back and check these answers and see if they match your perspective too, and let me know in the comment section if you had everything right already, and give me your opinion on if I got everything right, or let me know if I missed something.
What is a web server?
A web server is a computer that stores and delivers web pages and other web content to clients over the internet. It processes requests from web browsers, clients, and sends back the requested resources, such as HTML pages, images, or scripts. What is a network? A network is a collection of computers, servers, and other devices interconnected to share resources and communicate with each other. Networks can be local LAN, within a home or office, or wide-ranging WAN, spanning across cities and countries. What is the Internet? The Internet is a global network of interconnected networks that use the TCP/IP protocol suite to link billions of devices worldwide. It enables communication, information sharing, and access to resources such as websites and services. What is an IP address? An IP, Internet Protocol, address is a unique numerical identifier assigned to each device connected to a computer network using the IP protocol. It allows devices to communicate with each other over the Internet or a local network. What is a router? A router is a networking device that forwards data packets between computer networks. It connects different networks and directs traffic between them, enabling devices within those networks to communicate with each other. What is an ISP? An ISP, Internet Service Provider, is a company that provides access to the Internet for individuals and organizations. ISPs offer services such as Internet connectivity, email services, web hosting, and more. What are packets and how are they used to transfer data? Packets are units of data transmitted over a network. They contain information such as the source and destination IP addresses, sequencing information, and the actual data being transmitted. Packets ensure efficient and reliable transmission of data by allowing it to be split into smaller chunks that can be routed independently. What is a client? In networking, a client refers to a computer or device that requests services or resources from another computer, typically a server, over a network. Web browsers are examples of clients that request web pages from web servers. What is a server? A server is a computer or device that provides resources, services, or data to other computers or devices, clients, over a network. Servers can host websites, store files, manage email, and perform various other tasks. What is a web page? A web page is a document or resource that is part of a website and can be accessed and viewed through a web browser. Web pages are typically written in HTML and can contain text, images, videos, and interactive elements. What is a web browser? A web browser is a software application used to access and view websites on the Internet. It interprets HTML documents, retrieves resources like images and videos, and renders web pages for users to interact with.
What is a search engine?
A search engine is a web service that allows users to search for information on the Internet. Examples include Google, Bing, and Yahoo. Search engines use algorithms to index and retrieve relevant web pages based on user queries. What is a DNS request? A DNS, domain name system, request is a process where a client computer queries a DNS server to translate a human-readable domain name, like google.com, into an IP address. This translation allows the client to locate and connect to the correct web server hosting the requested website. Which browser are you currently using?
Okay, this is personal.
I'm using Brave, but usually for working-related things I mainly use Google Chrome, because that's one of the most used, and when developing a website we usually need to check his responsiveness. We might even need to test things in more than one browser to verify that too. In your own words, describe the process that takes place when you initiate a search on google.com in terms of what we discussed on this section. So, when you type google.com in your web browser, first, your browser checks its local cache for the IP address associated with google.com. Second, if not cached, the browser sends a DNS request to a DNS server to resolve google.com to its IP address. Third, once the IP address is obtained, your browser sends an HTTP request to the web server at that IP address. Fourth, the web server at Google receives the request and processes it, retrieving search results. Fifth, the server sends back the requested data, search results, in the form of HTML pages, along with any other necessary resources like images and scripts. Sixth, your browser receives these resources and renders them, displaying the Google search results page for you to view and interact with. There are here some additional resources, so feel free to explore and learn more about some topics you have more interest to. So, that's it for this lesson. Understanding how the internet and web infrastructure function is fundamental in today's digital age. From the basics of IP addresses and networks to the intricate workings of DNS, web servers, and browsers, each component plays a crucial role in enabling seamless communication and information exchange across the globe. By grasping these concepts, you gain insight into how data is transmitted, how websites are accessed, and how services like search engines facilitate information retrieval. This knowledge not only empowers you to navigate the internet more effectively, but also forms a solid foundation if you're interested in web development, networking, or digital communications. Moreover, recognizing the roles of clients and servers, the significance of protocols like HTTP and TCP, the IP, and the mechanics behind domain names and DNS requests provides a deeper appreciation for the technologies that underpin our everyday online experiences. Continued exploration and learning in this field will further enhance your ability to utilize and innovate within the digital landscape, ensuring you stay informed and adaptable in an ever-evolving technological environment. I will mark this lesson as complete and see you guys in the next episode. Thank you for watching. If you found this video helpful, please don't forget to give it a thumbs up and subscribe for more content like this.